reason in this way that what we call experience is always determinate or classical. It's what, in a sense, we mean by classical information. We don't see Schrodinger's cat as being dead and alive. We see Schrodinger's cat as being either one or the other. And we don't see people as being located both here and there. We see them located in one place and saying one thing. So that's classical information. And from a fairly strict kind of quantum information theoretic perspective, the only place that one expects to see classical information is on a boundary between two interacting systems. If we think of classical information as only encoded on boundaries, and if we think of experience as classical information, then it's fairly natural to think that experience is what's happening on a boundary, because that's where the classical information is. It's not anywhere else in this very kind of strict quantum theoretic point of view. In that case, one can think of the universe, if you will, as this big system, which we can describe using at least a quantum formalism. And one can think of slicing it in various ways. So slice it in some arbitrary way. You've created a boundary. Now that boundary may not be stable. If the interaction across that boundary is very strong, then the boundary is not going to pick out two systems that one can talk about as if they're different. And formally, if the interaction is strong enough that the entanglement entropy across that boundary is large, then those systems don't really have separate identities. They're too correlated to be considered to be just exchanging classical information. But if the interaction across the boundary that you've picked is fairly weak, then the two systems are more or less independent of each other, and you can think of them as separate entities that have their own states and that are exchanging some relatively small amount of information with each other compared to the amount of information that they've got inside. And that's the place where the free energy principle is helpful, because it depends on this conditional independence of one system from another. If you've picked a slice like that, when you slice the universe up, then that boundary is going to encode some classical information. And I see no reason not to think of all of that classical information as experiential, or think of it in experiential terms. And we're very familiar with that in our own case, and we're reasonably familiar with it in the case of animals like us. And we have essentially no familiarity at all with it in the case of other systems. But I don't see any reason not to think of it that way for arbitrary systems that interact sufficiently weakly with their environments. So I would be either bold or crazy and just say we should think of experience in general as the classical information that's encoded on boundaries.